Hello. So in this video, I'm going to show you how to make one of these things, which is like a small generator that can power this LED, like that. You can also see that the rotor, which is the top piece, is hovering above the stator, and that is because of the magnetic bearing that's in here. So I'm going to talk to you about like how to make this coil, how to position your magnets, how to make this whole thing, and how to solder this so that the LED actually turns on properly. And it might take a while, so stay tuned. Okay, so the first step is for you to assemble all of your materials, and the materials list, if you need it, is on my website. If you're on YouTube watching this, you can find my website link in the description, and if you're on my website watching this, then you can just scroll down and you can see the materials list. After that, you can start printing things. So the first thing you're gonna need to print is this wheel for the coil winder. It comes in two parts. So there's the cover for it, and then there's the base. And then basically you'll wind the coil around this, and the diameter of this wheel is basically very specifically set so that it fits around the stator. So make sure you print it exactly like this, or else you're probably going to have problems. So you just print both these pieces, and then you can print the frame. So this is the frame. The coil winder will fit right here and then be able to spin so that you can wind the coil a lot easier than trying to wind it any other way. And then the frame has four pieces. There's this piece and then the two bottom pieces on the sides, which are the same piece, just flipped. And then there's this coil, like wire threading piece, which will hold the wire here as you're winding the coil so that it keeps it stable. Anyways, you're going to print all these four pieces as well, and then finally you're going to print the spool holder, which will hold the spool like this while you're threading the wire so that it can easily spin. And so that's this piece twice, and then this little bottom piece that you can use to attach them. You're going to use super glue to attach all of these things, but I'll go into assembly in a bit. After you print all of those pieces, which are for the coil winder, you need to print the rotor and the stator. So the rotor is just a little disc. It has indents for the magnets that go around the edge, and then the bearings that go on the top and on the bottom, and then this wider little hole is for the magnet, the top piece of the magnetic bearing. And then you have the stator, which has pegs, which are where you're going to put the coil around on top of the pegs. And then you're going to, well, it also has like the dowel in the middle. The dowel has a hole in it, so you can feed the LED through, so the LED is going to sit right here. And then you have a hole for the magnet, so the bottom half of the magnetic bearing. And yeah, you're going to print all of those things. All of the STL files are on my website, so again, link in description, or scroll. And yeah, it should take you a couple hours to print, but you got this. I believe in you. It's not the hard part for sure. Okay, so now I'm going to go through the assembly of the coil winder. So I'd recommend printing the coil winder first, so that while the rotor and the stator are printing, you can start assembling this and do some other stuff and actually build a coil. So the first thing to print is this wheel. It has two parts, like I said. There's the cover, and then there's the base. And basically there's actually another part to it, because I printed this little rod separately. So the cover actually has a hole where you can put this rod, and I mean, it's just like very simple, like cylinder you can just use to spin it. You're gonna glue this rod into the hole here, but make sure, please be careful not to glue the top to the base of the wheel, okay? Because you need to be able to take these apart when you have wound your coil, so that you can take the coil off, or else it's gonna be very painful to do it. So it just attaches like this. Again, do not glue them together, just leave them like this. You will use like a bolt and a nut to fasten them together when you need to wind the coil. Okay. The next piece is the frame, which will hold the coil winder. So like through this hole, you're gonna put a bolt, and then on that bolt, you're gonna have this coil winder will sit so that it can spin. Okay, so this has 4 pieces, like I said. You have the actual frame, then you have these two for the base, and it's the same piece, it's just mirrored essentially, and this piece has just a slot in it so that the base or the frame can actually sit in it. And then to assemble this, you just need some glue, some super glue. You put some super glue on the base, you slide it into the slot, and then you do that on both sides and wait for it to dry, and you should be good to go. Then there's this piece, which is to hold the wire, like I said, so that as you're winding the coil, the wire is not kinked. Basically, you just want to make sure that it's nice and smooth while you're winding the coil. This piece you can print separately, and there's a hole in it. You slot it through the hole. It's a pretty tight fit, so you don't even need any glue or anything. Just leave it like this. Okay. The final piece that you need is to hold the spool. So you hold the spool something like this, right? And so it's just 2 of these pieces. They're the exact same. And then you have the base, which is just basically a rectangle. And then the same thing. There's a slot in the spool, or in this piece of the spool holder. And then you can put some glue in it to hold it together. I'll wait for it to dry. Do that on both sides, and you should be good to go. Okay. Now to put everything together, make sure that basically you want the spool holder to be beside the thread. I don't know what to call it, like the slaughter. I don't know. But you can use these little divots in here, and then put them around that like this, and it should stay like they should. You shouldn't be able to take them apart. But you don't need to glue it. You can, but you don't need to. It's fine. And then you leave that like this. And then, like I said, you have your bolt. Okay, you're gonna put the bolt through. Let me do it this way. So you want the bolt, like the actual not the tail side of the bolt, to be on the same side as the wire threader, and then you're going to put a bearing on this side. Then you're going to put your wheel with the little rod facing again the same direction as the threader. Put that through, and then you're going to put the other bearing on it, and then you're going to put a nut. Okay, and then you tighten that down. The point of the bearings is just so when the nut is tight, you can still spin this without too much issue, and it still spins freely. Okay, this is your coil winder. It should look something like this, and basically you're gonna put your spool on. I use a little marker to hold the spool. Oh shit. Okay, let me do this really quick. Okay, so I use a marker to hold the spool, right? You can use anything. You can 3D print a little cylinder again that will fit through the hole in the spool, and then just hold it here. And then you have the end of the wire that will go through this hole like that, and then around this you wrap it around this knob. Okay, and then you can start winding your coil. I'll go into that in a little bit. Okay, so now we're actually going to wind the coil. So make sure you set up your coil winder like this, and then you can take your wire. You can try to thread it through here, and then you're going to put it around the wheel. Make sure that this little rod thing is at the top, and then you're going to wrap the wire around the rod a couple times, and then you're going to get some electrical tape, and then you're going to just place it on the rod just to make sure that the wire stays where it is, and then you can start winding the coil. So make sure that the coil is always pulled taut, so it's always like very tight against the top of this. Again, the wire should fit. I don't know if you can see that, but the wire right here, it should be between these two pegs essentially, and it should stay that way all the way around. So you're gonna turn it with the handle, and you're gonna turn it about 200 times. Could be a little less than 200, could be a little more than 200, just about 200 times. And being careful the entire time to make sure that the wire always stays between these two pegs. It might try to go on top of the pegs, it might try to go around the pegs. If it ever does that, make sure you put it back between, and then make sure that it's always tight. Okay, so sometimes this little thing doesn't work so well, maybe it falls out. You can just use your hands to hold it, make sure there's no kinks in the wire, and keep pulling it, keep turning it and turning it and turning it, and do that 200 times, and then it should be fine. Okay, now on the 200th turn, let's pretend that this is 200. Okay, you're going to take the end of the wire here, you're going to put it around the final peg with the rod at the top. So you should have the start right here, and then you should have the end right here. And then you're going to basically, well, your wire is going to look something like this. It's going to be a lot thicker than this is. And you're going to put tape, see this tape here? You're going to put tape between all of these little gaps. Okay, so you're going to take electrical tape and you're going to cut it so you have some nice thin strips. Give me 1 second. So cut like a piece about this long and then cut it in half. So up the middle like this. And then you're going to take this thin piece and you're going to wrap it around like that. Okay, I hope you can see that. So you're going to take the tape, you're going to wrap it around in each of these gaps like this, and then at the end you'll get something that kind of looks like this. Okay, and this will be around the coil. Then at that point you can cut the wire, make sure that you have a little bit of space, so like basically a little bit of a gap between the actual wheel of the coil and then the end of the wire, so that you can use this to, you're going to use this later for when you're threading to actually power the LED or anything. So yeah, make sure you give yourself some room, give it a nice cut, and then after you've done that, you can take the nut off, take off the bearing, take off the wheel, separate the wheel, and then you can remove the coil. But make sure that you have all of the tape in each of these gaps before you remove anything. Okay? Sounds good. Okay, so hopefully by now your rotor is done printing. And it should look something like this. So there should be 20 holes for magnets around the edge, and then a hole for the bearing at the top, a hole for a bearing at the bottom, and then a little indent for the top of the magnetic bearing. So first thing you want to do is you need to put the neodymium magnets into these 20 holes, and you need to do that in a specific arrangement. So it should basically, each magnet has a pole, the north pole and the south pole on the opposite sides, and then you want the side, basically the pole facing outwards, to be alternating as you go around. So north pole, south pole, north pole, south pole, north pole, etc. The easiest way I know to do that is to take a stack of magnets like this. You know that the pole is always facing the same direction, and you're going to put one in one of the holes, slide it out. It doesn't matter what hole you start with, but then put one here and then skip a hole, and then put another one, then skip a hole, put another one. So you're just going to go around like this with the magnets facing the same direction all the time, and just go every other hole, put a magnet in it. So let me do that really quick. So now you should have, every other hole should have a magnet with the same pole facing it. And then you're going to take your stack, turn it around, and put a magnet in every remaining hole. So you should notice that if you try to push one of the magnets that's currently inside the hole and your stack, they should repel each other. So they should not want to go together. They should resist going towards each other. And then you're going to put them in the remaining holes all the way around. Okay, now at the end you should have magnets in all of the 20 holes, and they should be alternating. So one way to verify that, if you did it the way I just explained, it should already be good. You should not do anything, but basically you just want to take another stack of magnets or some other magnet and test that if you put it between one, it attracts, and then if you go on either side, then it should repel. Okay, so the middle one here, it attracts the magnet, but the other two on either side of it, they repel the magnet. And if that happens, then you know you did it right. Do that for every magnet around, and you should be fine. Okay. Next, you're gonna take the bearings. So these are just two regular skateboard bearings. You're gonna put one of them in the top. Just press fit. It shouldn't come out, and then one in the bottom in the hole right here. It shouldn't come out. And then you're gonna take your ferrite ring magnet. So you're gonna put this on top of this bearing, on the bottom, just like that. And that is the rotor fully assembled. Okay. Now we're going to talk more about the positioning of this magnet in a bit, but that really only matters that it's the same face facing that's going to be on the stator. But I'll go into that in a second. Okay, now we're going to assemble the stator. So your stator, when you're done printing, should look something like this. It should have 20 little pegs. That's for the coil to stick on. And then it should have a hole, a dowel with a hole going through the center of it. And then a little indent, which is where the magnet is going to go for the magnetic bearing. You should have your coil that you just took off of your coiler. It should be circular with all your tape on it. And what you're going to do is you're going to just pinch each of these strands of tape, and then you're going to bend it like this and try to get, just do that all the way around, try to get equal bends. So bend one side up, then bend the other side down, and then do that all the way around to get like a zigzag pattern. I will do that and then show you what it looks like at the end. Okay, so once you're done bending it, should look something like this. And the tape just makes it very, very easy to bend it into shape. Once you're done, you're going to want to kind of extend it a little bit and kind of twist it out so that you get kind of like a 10-pointed star. Something that looks like this. And that is what's going to go on your stator. So then you're going to take these two leads and you want to follow them through this little hole right here. Just like this. And then you want to pull it tight. Now you're basically just going to put the coil around these pegs. So the point of the star should go on the top side of the peg, and then the little divot in the star should go on the bottom side of the peg, and it should just be like a zigzag pattern all the way around. So I'll do that and show you what it looks like when it's done. Okay, so it's going to look something like this with the coil going around each of the pegs. And ideally you want it to be as flat as possible, so you want the base of the coil, so the bottom of the coil, to be on the base and be like completely flat, ideally. Sometimes it is a little bit hard to do that, so what I do is I will take a little push pin and basically go like this and push the top of the coil around whatever peg is being a pain in the ass and push it down so that it becomes flat. It just needs to be mostly flat because the rotor is going to basically hover on top of the coil, and you do not want it to brush anything because that will basically create friction and create a loss of energy. So try to make it as flat as you can, and it should be something like this. And that should be good. Now you're going to want to take this magnet, okay, get your rotor back, and you want to make sure that these two magnets repel each other, because that's going to be your magnetic bearing. So just push them together, and if you feel them resisting each other, then that's good. If you feel them attracting like this, that's bad. So then you just flip it around, make sure they're resisting each other, and then you're going to take the side that repels when they come together, put this side up on the stator. So this side up like this, okay? And then you're going to take your rotor and you're going to put it like this, and you want to make sure that the rotor is hovering. If it's not hovering, then the magnets are too far apart. So what I did is I printed these little washers, and these washers just kind of serve as spacers. So you put the washer on top in the hole, and then you put the magnet on top of the washer so that it's a little bit closer. And now you should see that it is a little hovering, just a little bit. So it shouldn't be touching, and when you push it down, it should kind of spring back up. If it is still too close, you can print a thicker washer, or you can kind of stack washers. So you can add another one, then put the magnet on top of that one. And now you should clearly see that the magnet is hovering. Okay, and then when you push it down, it should spring back up. So now that you know it's good, and it should be able to spin pretty freely without too much friction. Just make sure that it's not rubbing against the coil, and you should be good. Okay, so that's it for assembly of the rotor, or sorry, the stator, and then the rotor. Next, I'm going to talk to you about how to start soldering things. Okay, so now we're going to start soldering stuff. You're going to need an LED, color of your choice. I'm going to use green. And then a 220 ohm resistor. Also, obviously, soldering iron. Some wires to connect to the leads of the LED. And wire strippers for jokes, I guess. What you're going to want to do is solder the resistor to the positive lead, which is the longer leg of the LED. It doesn't actually matter which one you solder it to, but just solder to the longer lead. To do that, kind of bend it back. I'm going to trim my resistor because it doesn't need to be so long. Okay, I like to bend them around each other so I can solder them. So I just bend the resistor leg and around the LED leg, and then you're going to make a solder joint. Okay, very simple solder joint. If you can see it, yeah. It's not the best solder joint, but it's going to be good enough for our purposes, I think. Then you could take, well, I'm going to take some heat shrink and put it over this. You could also just use some electrical tape, just wrap it around. You just need some insulation. Okay, you're going to take heat shrink, put it around the LED and the resistor on the lead, and then I'm going to shrink it. Okay, something like that. And then you're going to take these two wires, red to positive, obviously. I mean, you don't need to do that, but helps. I'm going to strip a little bit off. Strip a little bit of coating off, so you have some exposed wire. And then I'm going to do the same thing. So remember that the resistor goes to the positive lead. And then I'm going to just create a joint like this. It's not the most efficient joint, but I think it does the job. I'm going to solder that. Okay, and that's another solder joint. You're going to put a heat shrink over that too. And then finally, the black wire is going to go to the negative lead of the LED. So you're going to strip this. And that's the LED done. So there shouldn't be too much exposed metal on it. You just want the two wires coming out the bottom, and then you're good to go. Okay, so now we've come to like the second last part and probably the most complex part of the tutorial, but it's not that complex once you understand what you're doing. I'm going to try my best to explain it, but essentially we're going to be building this thing, which is called a full bridge rectifier, which is just 4 diodes, which are these black things in the middle here. So 4 diodes with a capacitor, which is this thing that kind of looks like a battery, and then the 2 screw terminals, which are just for connecting the wires. Okay, so how a rectifier works is it takes the current that's generating the current that is created by the generator, which is alternating current, and then it rectifies it into direct current, which we can use to power things like LEDs. So how it does that is with this special arrangement of diodes. Okay, so what you need to know about a diode is it's a special piece of hardware that only allows current to flow in one direction. Okay, so it flows from the anode, which is the part without the stripe, to the cathode, which is the part with the stripe. Okay, so it only flows in one direction, and then the diodes are arranged so that all of the stripes are pointing downwards. Okay, so stripes always point down, so current always flows down. And then we connect things in a certain way. So we will connect this capacitor. The positive side of the capacitor we will connect to the bottom of the rectifier, and then the negative side of the capacitor we will connect to the top side of the rectifier. And then we will connect the lead from the generator, so these 2 wires right here, they will connect to either side of the rectifier. Okay, and what this allows us to do, or what this does essentially, is current will flow from the generator. It will flow into one of these sides, and then it will flow down into the capacitor, and then it will flow from the capacitor, from the positive side to the negative side, and then back into the rectifier, and then down into the other side of the generator. So if we get current from, let's imagine that the current is flowing clockwise, so we're going to get current coming from the right side, well, right or left, whichever way it's going to mirror itself, but it's going to be, let's say left side of the rectifier, down into the capacitor, out, back to the rectifier, and then down the right side of the top. And then if the current is flowing the other direction, so counterclockwise, it's going to hit the other side. It's going to go down into the capacitor, out of the capacitor, back into the top of the rectifier, and then down the other side and back into the coil. So I hope that makes sense. If it doesn't make sense, there's a million YouTube videos that explain it much better than I did. All you need to do here is solder it. Okay, so you're going to take 4 diodes. Okay, 4 diodes, and you're going to take a PCB. You're going to take your capacitor and your 2 screw gate terminals. Okay, you're going to arrange the diodes in the same pattern as this, essentially, and just make sure that all of the stripes point down. That's all you need to do. Let me finish that real quick. Okay, so you're just gonna position them like that. Notice that all of the stripes, so the gray side, they're all pointing downwards, so they're all pointing in the same direction. And then on the back, you just crisscross all the legs, and you're gonna solder these after. But we're just gonna place everything on the board nicely. I left some space on this side so that I can put the screw gate terminal in a bit. But first, we're gonna put the capacitor on. So make sure that the capacitor is polarized, so it has a negative side, which is the shorter leg, and then it has a positive side, which is the longer leg. You want to put the negative side, it should be, well, in the direction of the top of the rectifier. Okay, so you're going to put it in. Okay, and then the negative side of the capacitor, it has like this indicator for negative. It's going to be in the direction of the top of the rectifier. Okay, and then the positive side is pointing towards the bottom of the rectifier. And then what you're going to do with these, so the capacitor needs to connect to the basically either side of the rectifier. So for now, there's the legs of the capacitor, and I bent them around the legs of one of the diodes. So each one of these joints, like each one of these crisscrossing wires, they need to be connected. So the diodes need to be connected here, 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 and here, and we're going to connect them by soldering them, okay? And then we have to connect the capacitor to the top, so the negative side of the capacitor to the top of the rectifier, which is this, and then the positive side of the capacitor to the bottom side of the rectifier, which is here. And we're going to do that all by soldering, okay? Yeah, I mean, once you have this part, you can actually start soldering the connections here. And then once you've soldered those on, or well, honestly, you can also put the screw gate terminals here. So all this is it's a way for you to, like, there's these little holes here that you can put wires into. And then there's a screw at the top that you can screw down so that the wire has a form connection. So it allows you to connect things without having to solder everything. So you can disconnect it later, which is, I think, is very nice. So you're going to put the screw gate terminal on either side. So you're going to put one right here beside the rectifier with the gates or the terminals pointing outwards. And then you're going to put another one beside the capacitor with the gates pointing the other direction. So it's going to look like this, okay? And then you're going to solder everything. So what you need to do, so this screw gate is very simple. This is going to connect to the capacitor, essentially. So you're going to use some kind of wires to connect these legs, these leads, to the bottom of the capacitor so that they have a solid connection. And then you're going to connect this terminal on this side. It needs to be connected to both edges. You see, like the left and right side, right here. So that's where we're going to plug in the generator so that we can basically power the whole thing. So we're going to use some magnet wire. I mean, this is just any kind of wire is fine. You just need to be able to connect. You just need to connect from these legs across here, and then one to across right here. And then on this leg, you need to connect to either side of the capacitor. When you're done, it looks something like this. Okay? Excuse my very bad soldering joints, but you see that I have one screw gate, which is next to the capacitor, and that is connected to the capacitor with these little copper wires. Okay? And then you have the other screw gate, which is on this side, which is connected across. So you have a connection to this side of the rectifier and then this other side of the rectifier, and that's done with this magnet wire here. Okay, so this is going to be what the finished product looks like. Just make sure that all of the connections are proper. Maybe I'll make a nice wiring diagram to make it easier. I should probably do that. And yeah, then solder everything together. I'm not going to teach you how to solder. There's like a million YouTube videos on that. So just figure out how to solder and then make all of the connections and you'll be good to go. Okay, so now we're at the last step. We should have our nice rectifier with everything soldered properly. Make sure that you don't accidentally connect two things that shouldn't be connected. I will put up a wiring diagram either like here but definitely on my website. And yeah, just make sure you follow that and you only connect the thing that need to be connected and you don't connect anything else, or else it's probably not going to work. Okay, so that should be good. You can snap off the ends of the PCB because you want it to make it a little bit smaller so that it can fit on the bottom of your stator like that. Now we're going to start actually putting everything together. So you take your LED with your two long leads and then you're going to thread it through the hole that's in the center of this and then you're going to pull it through. It'll be a bit of a tight fit, and that's why we used the heat shrink or the electrical tape to isolate or to provide some insulation between the two leads so they don't touch each other. And then you should have them coming at the bottom like this. Okay, now you're gonna basically connect all of your wires to your PCB. So the two, like I said, the two or the screw gate next to the rectifier, next to the diodes, is for the coil. So for the coil leads, you're going to stick them in. Before you do that, make sure you sand the ends, like the tips of each of these wires. The reason you do that is because there's an enamel coating on the wire so that it's basically insulated from itself. So you want to sand that off so you can get a good connection with the terminal. So do some sanding. I've already done that. And then you will, let's just do it like this. So you're going to have it like this. You're going to put the wire inside the terminal. And then you're going to tighten it. And then when you try to pull, it shouldn't come out. So it should be a very solid, tight connection. And then you're going to do the same on the other side. Make sure it's very tight so you can't pull this one out either. And like I said, the order of these two leads don't matter because they're alternating anyways. So you just need both of them in. Okay? And now we're going to do the LED wires to the other side of the terminal. So this one does matter. So the green wire is positive, so we need it to be on the positive side of the capacitor. And remember that the positive side of the capacitor is the side without this indicator. So this indicates negative, and the other side is positive. So negative here, positive here. So we're going to put the green one on this terminal. So shove it in there to make sure that there's a good connection and it's not going to come out. And then you screw it down. Make sure it's really tight and it should not be able to come out. Okay, and then same for the black wire. We're going to put this in to the negative side of this terminal. And make sure that it doesn't come out. And then you should be good. So be careful again. The wires, so the wires from the generator, from the coil, they don't matter. They can go on either side, it doesn't matter. But the wires from the LED that goes through, the black one needs to go to negative. Or if you use different colors, just make sure that the negative lead of the LED goes to the negative part of the capacitor, because that's very important. Okay, now you're done. You're going to put the rotor on top of the stator. Notice how it kind of hovers there. And then, in theory, everything should be working. Everything should be wired properly. When you spin it, the LED should turn on. We're going to try. Oh yeah. There we go. And when you stop it, the LED turns off. When you spin it again, it turns back on. So, now you're done. I'm very happy that that works. If you follow those steps, you should have a working generator. Good job, I guess. I've put some possible extensions on my website. So if you wanna you can do a lot with this. Like I made the LED turn on just because that's the simplest thing you can do with it. But you could in theory charge your phone with a generator. You could spin a motor. You could do a bunch of stuff. There's a bunch of extensions on the website in the tutorial. And yeah, I hope this is interesting for you. It's kind of a cool project. You can also glue this to the bottom here and get the wires out of the way so it's not extruding and just hanging there, because that's kind of weird. But you're done. You have a generator. You can do whatever you want to do with your generator. Have fun.